Unit 2, Lesson 5, page 3, skill number 3. Given the description of two lines, determine whether the lines would be parallel, perpendicular, or neither. In business, it is common to graph two straight lines on the same graph to compare trends or find the intersection of where they cross. Consider that two lines can be perfectly parallel, never crossing, perfectly perpendicular, crossing exactly at 90 degrees, or crossing at a different angle. The relationship of two lines that cross at the degree other than 90 is labeled neither. So we have parallel, perpendicular, and neither. The three ways they classify the way two lines can cross on the same graph. Okay? So again, if you're given the description of two lines, so find the slopes that go through, find your slopes from 2 points. So they're describing, think about it, they're describing a line. So 2, 2, and 3, 4, there's a line. This isn't graph paper, so I'm not sure that's exactly it. And then I have another point that's 5, 8, and 7, 8. So that sounds kind of straight. Okay, so, oops, 5, 8, 7, 8. Yeah. Why is it going that way? So much for that idea. All right, Unit 2, Lesson 5, page 3, Skill 3. Given descriptions of two lines, determine whether the lines would be parallel, perpendicular, or neither to each other. All right, we're describing the relationship of the lines, two lines on the same graph. So in business, it's common to graph two straight lines on the same graph to compare trends or find the intersection where they cross. Supply, demand, that kind of thing, right? Consider that two lines can be perfectly parallel, which means they never cross, perfectly perpendicular, which means they cross at a 90-degree angle, or they cross at a different angle. The relationship of the two lines that cross at a degree other than 90 are labeled neither. So three classifications: parallel, perpendicular, or neither. So they can describe a line of a graph many different ways. Sometimes they'll give you 2 points. Sometimes they'll give you equations. So this is very similar to what we just did. It's just a different way we described parallel, then we described perpendicular. Now thrown in there is maybe a neither choice. Okay. So if you're given two lines, you put them in the slope formula and solve for your slope. Did I say two lines? I mean 2 points. Given 2 points, put them in the slope formula. Remember the m equals y2 minus y1 over x2 minus x1, right? Plug them in, label these and plug them in. This one gets a slope of 2. This one has a slope of 0. So the slopes are not the same. Therefore, and they're not reciprocal, so they're neither. Let's look at that for a second. If you have your graph and you have 2, 2 and 3, 4, there's a line that's going like this approximately. Okay, then you have 5, 8, and 7, 8, and this line goes like this. Clearly not parallel. They're going to cross each other. Okay, so all we're asking is, do they cross at a 90-degree angle? No. Are they parallel? No. Therefore, they are neither. That's all. Okay. So we have to find the slope first. In this category, you have to recognize this is in slope-intercept form. The numerical coefficient is this of this term. In front of the x is a -1. Okay, so if it's just a negative, it's a 1. If it's just an x, it's a 1. Okay, so 1s are in front. This one I have no idea. This is in general or standard form, so it needs to be turned around. So before we can just categorically say what the slope is. That's why we practiced what we did on the front. Y equals 1x, I'm just going to go ahead and put the 1 in there, plus 2. So my slope is a 1. These are tricky. A 1, the reciprocal of 1 is still a 1. Okay, its opposite sign is negative. So this one's an odd case where these lines are actually perpendicular to each other. I don't know if I got room to sketch that in here, but this y-intercept is a positive 2. This y-intercept's a positive 2. And 1 is a positive 1. And 1 is a negative 1. So they're going to cross at a 90-degree angle. Okay. They can cross anywhere. It doesn't necessarily have to be on the y-axis at a 90-degree angle. It just so happens that this one does. If you had graph paper, it might be easier to see. All right, so step 1, here's our equation. You have to notice that this is in point slope form. So it's telling you, the information it's giving you is this slope for A is 1/4. This is also in point slope form, so this slope is -4. That sounds like it's also perpendicular. Okay, so when you're working on these, some people expect them to have one of each. That is not necessarily so at all. You cannot assume that. Okay, so do them what you're supposed to do for all of them in the homework. All right, and the bottom one says, given a line of an equation, find the slope of the line that would be parallel or perpendicular to that line. Okay, so find the slope of a line that would be parallel to this line. Well, I have no idea what this line looks like until I put it into slope-intercept form. So I'm going to move the x over, and then I'm going to divide by 5, and this is my equation of the line in slope-intercept form, which means this is my slope. So a slope of a line that would be parallel to this given line would be the same. So my answer is 2/5. Okay. Here's another one. Number 2, find the slope of a line that is perpendicular to this line. Well, I have no idea what the slope of this line is yet. So let's move this over. -4y equals -3x plus 2. Isolate my, that's a 4. Isolate my y. Y equals double negative 3/4. 1 negative and reduce 1/2. Don't really care about the b. I did all that to find out the slope of the given line is a positive 3/4. So a line that would be perpendicular, the slope of a line that would be perpendicular, what would be the perpendicular slope of 3/4? Well, this is a positive 3/4, so this would be a negative, and then flipped it would be 4/3, and that is all they're looking for there. Okay.